All right, let's get straight into it. If you're revising for your AQA GCSE Physics exam, then you are in the right place. We're going to do a quick fire explainer on a really core topic, work done and energy transfer, which, if you're following along, is section 4.5.2. Okay, let's get stuck in.
So, first things first, when you hear the word work, you probably think of homework or chores or maybe your part-time job. But in physics, it has a super specific meaning, and you've got to get your head around that before we go any further.
And here it is, the official definition straight out of the AQA spec. The key thing to notice here is that for work to actually be done, two things must happen. Number one, you need a force. And number two, that force has to actually make the object move over a distance, a displacement. If it doesn't move, no work is done. It's as simple as that.
Now, since this is physics, of course, there's a nice, simple equation for it. And this one, you absolutely have to know it for the exam. It's W equals Fs. That's work done equals force multiplied by the distance. This little formula is your best friend for any calculation questions on this topic.
Okay, let's just break that equation down. W is for work done, and we measure that in joules, or J. We'll talk more about joules in just a second. F is our force, which, as you know, is measured in newtons, and S is the distance. Now, this is really important. The distance has to be in meters, okay? If they give it to you in centimeters, you've got to convert it first, otherwise the whole thing falls apart.
So, what on earth is a joule anyway? Well, this definition tells you everything you need to know. It's not some weird, abstract idea. It's tied directly to what we've just been talking about. If you use 1 newton of force to move something 1 meter, then congratulations, you've just done exactly 1 joule of work. It's a perfect little relationship between force, distance, and work.
So, when we're talking about that 1 joule of work, we're talking about a very specific thing. We're talking about the work done by 1 newton over 1 meter, which means that 1 joule is basically
Exactly the same as 1 newton meter. That's it, seriously. They're just two different names for the exact same thing. So don't get thrown in an exam if you see newton meters instead of joules. They are totally interchangeable. And remembering that is a really easy mark to grab.
Okay, so we can define work, we can calculate it, but why do we actually care? What's the point? Well, this is where it gets really interesting, because this idea connects to one of the biggest, most important concepts in all of physics.
And here it is. This is the absolute golden rule. When you do work, you are transferring energy. That's it. They're the same thing. The amount of work you do is precisely equal to the amount of energy that gets transferred. And that's why they're both measured in joules.
Let's think about a classic example. Imagine you're pushing a really heavy box across the carpet. You're pushing it, it's moving, so yeah, you are definitely doing work. But you're also fighting against friction, right? So where does all that energy you're putting it actually go? Does it just vanish?
Let's follow the energy. So you apply your force, the box moves, and work gets done. But that work you're doing against the friction doesn't just disappear. It gets converted, transferred into thermal energy. In other words, the bottom of the box and the carpet it's sliding on actually get a tiny bit warmer.
And that's the key principle you need to nail down for your exam. The energy you transferred by doing all that pushing work has now increased the thermal energy store of the box and the floor. And that's why their temperature goes up.
Right then, let's wrap this up. We're going to do a super fast summary of the absolute essentials, the stuff you really need to have locked in for your exam.
Okay, so to recap. 1. Work is a force causing something to move. Got it? 2. That equation, W equals Fs, know it inside and out, along with the units. 3. Work is measured in joules. 4. A joule is just a fancy name for a newton meter. And finally, the most important bit, work done is the same thing as energy transferred.
So, I'll leave you with a final thought, a little question to bridge this to the next part of your revision. If doing work is all about transferring energy, and you do work to get that box moving from a standstill, what kind of energy store are you actually filling up? Have a think about that, because if you can answer it, you are perfectly set up for the next topic, kinetic energy. Good luck.